Hello viewers. Now today let's talk about discriminants. Now today we have these two questions, okay, to solve. Now the first question is to prove that the inequality 3x² plus 13 less than 12x has no real solution. Now the second question, we want to show that there is no real value of the constant c for which the equation cx² plus 4c plus 1x plus c plus 2 equals to what? 0 has a repeated root. Now, when we talk about discriminant is a quantity which is equal to b square. Okay, the quantity because the Greek capital letter, okay, for discriminant is what we call delta. Okay, so the quantity delta, okay, which is equals to b square minus 4ac, okay, is the discriminant, okay, is the discriminant of the quadratic equation ax² plus bx plus c equals to 0. And you know, the type of root that a quadratic equation has, you know, depends on the value of discriminant. So there are three different values of discriminant. There's the one that when the value of the discriminant is positive, then the associated quadratic equation will have two distinct real roots, okay? But when the value of the discriminant is less than 0, then the associated equation will have no root, okay? Then the last one is when the value of the discriminant is equals to 0. Okay, you know, when the value of discriminant is greater than 0, so that means when we have values from 1 to 1, 2, 3 and all of that, those are values greater than 0. Okay, that's natural numbers, okay? But when the value is less than 0, then it has no real root, okay? But when the value of the discriminant is equals to 0, just like question B, okay, then it will have what we call a repeated root. Because when a quadratic, for a quadratic equation to have a repeated real root, okay, then it means the discriminant of the quadratic equation must be equals to 0. That is, we're going to set this guy, okay, this quantity, we're going to set it equals to 0, and we know that this quantity is equals to b square minus 4ac. Let's talk about discriminants now. Let's consider, okay, the quadratic equation. Consider the quadratic equation ax² plus bx plus c equals to 0. Okay, now when the discriminant is equals to 0, okay, now the associated equation, okay, the associated equation will have, okay, the associated equation has two distinct real roots, okay? But now when discriminant is less than 0, okay, the associated equation, that is the quadratic equation, okay, has no real roots, okay, because it is less than 0. That's when we are getting negative value, okay, when the value of the discriminant is negative, okay, so it means it will have what? The associated equation has no real root. But when the value of the discriminant is positive, that is when the value is positive, then the equation will have two distinct roots. That is when the parabola, the curve, okay, will cut the x-axis, okay, at two different points. You know, that is when we say a discriminant has two distinct real roots. So for each, we can analyze each case. Okay, when the discriminant is greater than 0, this is the y-axis and then this is the x-axis. So the parabola will cut the x-axis at two different points, okay? It will cross the x-axis at two different points. Then also, when the discriminant, okay, is less than 0, when the discriminant is less than 0, then the parabola will lie entirely, will lie entirely above x-axis. That means it does not cut the x-axis. Okay, it does not cut the x-axis at all. Okay, that's in the case of when the discriminant or when the associated equation has no real root. But when the associated equation, okay, is equals to 0, when we have the discriminant to be equals to, that is when the discriminant of the associated equation is equals to 0, then the parabola, okay, will touch the x-axis at a point, okay, and that is why in that case we are going to have a repeated root, a repeated real root. So when the discriminant, okay, is equals to 0, so we have here that the associated equation, okay, the associated equation has a repeated, okay, real root, a repeated real root, and that's exactly what I explained here. I've explained here. Okay, so now quick one. Now we want to prove this guy. Okay, we want to prove why this inequality 3x squared plus 13 less than 12x has no real solution. I already explained that here. So the first thing is to what? Is to rewrite the inequality, okay, to a standard quadratic form. Okay, that is, we're giving 3x squared, okay, plus 13 less than 12x. Like I said, we are going to rewrite the inequality to a standard quadratic form. So let's rewrite it to a standard quadratic form. So that means it's going to be 3x squared, okay, negative 12x plus 13 less than 0. Okay, so we can now write this inequality, we can replace the inequality sign or symbol with equality symbol, okay, so that we can then use discriminants, okay, to find out whether or not this does not have a solution. I already explained the discriminant, okay, so whatever we get already, it already analyzed I already explained each case, when it is greater than 0, when it is less than 0, and when it is equals to 0. So in this case, I can write this to be, the equation will be negative 12x, that's 3x squared minus 12x plus 13 equals to 0. So we have our discriminant to be b squared negative 4ac, okay, b squared negative 4ac. So from this equation, a is 3, now b is minus 12, and then c is what? 13. C is 13. So with this now, we should be able to what? To find out whether or not this does not have, the inequality does not have what? Real solution. So now we know that b squared, so when we write b squared minus 4ac, okay, so that will be minus 12 raised to the power of 2, okay, then 4 multiplied by 3, then multiply by 13. Okay, so this will be 144 minus, so we have 12 times 13, because 4 times 3 is 12. So 12 times 13, 12 times 12 is 144, okay, 144 plus 12, that will be 156. Okay, so this will be 156, and we know 144 minus 156, that will be negative 12. Yeah, that will be 12. Okay, yeah, that will be negative 12. So we can see here that the discriminant is what? The discriminant, okay, so because now we have discriminant to be what? Discriminant is negative. Discriminant is negative. So we can say, therefore, the inequality 3x squared, okay, plus that's minus 12x plus 13 less than 0 has no real roots. Okay, if you want to analyze it further, okay, just like what I explained here, that means the parabola, okay, the parabola of this equation, that is this quadratic expression. You know, another thing again is the discriminant of a quadratic equation, okay, tells us whether the associated graph of a quadratic expression, okay, whether it, you know, cuts the x-axis at two different points, which is the first one, okay, or it does not cross the cut the x-axis at all. Okay, that is when it will lie entirely above the x-axis, and that's what we have here. So that is in the case of no real root. Then when it touches the x-axis at a point, then that is when it has a repeated real root. So in this case, we just prove why the inequality 3x squared minus 12x plus 13 less than 0 has no real root. That is explained. All right, so we have this proved already. Okay, proved. All right, so for B, we are given that we want to show that there is no real value of the constant C. Okay, now there is no real value of the constant C for which the equation cx squared plus 4c plus 1 parenthesis 4c plus 1 x plus c plus 2 equals to 0 has a repeated root. Now we know that for a quadratic equation to have a repeated root, okay, the discriminant must be equals to 0. So we want to show, okay, to show that cx squared into then plus 4c plus 1x plus c plus 2 equals to 0 has a repeated real roots. The discriminant of the quadratic equation, which is the associated equation, must be equal to what? 0. So this guy must be equals to 0. Yeah. So now, and we know that this discriminant is b squared minus 4ac. Now, so according from this equation, we have so a would be c, b would be, that's a is the leading coefficient of x squared in a quadratic equation. All right, that's the general quadratic equation. Now b is 4c plus 1. Okay, so we have that to be 4c plus 1, and then c equals to c plus 2. Let's leave it that way. Okay, let's leave it that way, just for, you know, just for those who are learning this for the first time, or maybe you've learned this about this before. You're going to learn this concept again, you know, and to see how it works out, okay, when we use the general quadratic equation. So that's why we should maintain this. Okay, so now we have a equals to c, which is the coefficient of x squared. Okay, now we also have 4c plus 1, which is the coefficient of x, and also c plus 2, which is the constant. Okay, so now, so we're going to write, so we use b squared minus 4ac, using b squared minus 4ac. So that implies that, okay, equals to 0. That is repeated roots. Okay, so we then have b to be 4c plus 1 raised to the square, okay, raised to the power of 2, minus 4 times a, which is what? C, multiplied by c plus 2 equals to 0. So let's expand. Let's expand the square of 4c plus 1. That will be 16c squared plus 8c plus 1. Okay, so if we move this to the other side, we're going to have 4c squared. That is 4c times c. That will be 4c squared. Then plus, that's after we move it to the right hand side. Okay, so that this will be 8c. Okay, so now we can now combine like terms. Now we have AC, we cancel out from both sides. Okay, that's when we subtract 8c from both sides. the equation reduced to 16c squared plus 1 equals to 4c squared. So we again combine like terms. So combining like terms, we have c squared minus 4c squared equals to -1. So when we combine like terms, so that in this case we are going to have 12c squared equals to -1. So that c squared will be equals to -1 over 12. So what this tells us is that the square of a real number does not have to be negative. But in this case, we have the square of the real number c to be what? Negative. So which means the value of c in this case will be negative. And in that case, that means that this equation has no real value. Real number is a number which is either rational or irrational. Okay, so the square of a real number shouldn't be a negative value in this case. Okay, so because we have c squared equals to -1 over 12, so in this case we can say that, okay, since the square of a real number is not negative, but in this case the value of c is what? Negative. So since the square of a real number does not, let me put it that way, let me put it this way, does not have to be what? Negative. Okay, then the given equation, that is this equation, okay, has no real value of constant c, has no real value of constant c. And this just explains why we have c squared, okay, to be equals to the square of a real number, okay, does not have to be what? Negative, or is not negative. Then the given equation has no real value of constant what? Of constant c. The noblest pleasure is the joy of understanding. Bye bye.